Hi, welcome back. So it has been long since I posted anything. I was just waiting for more neck papers for me to do for you. I'm going to thank all of you from all over Kenya and all other schools for the much effort that you've put in and for what you have done in gaining the knowledge that I'm giving you. So I'm thanking every and each of the students out there. Yeah, continue learning, and I will continue giving you the right content for you to feel welcome, for you to gain a lot of knowledge that you're going to use in your later lives and also in the school curriculum for passage of these examinations from NEC. Yeah, today we are going to look at a question on the Math Series 2023 done by the Craft in Land Surveying students. The question was a little bit challenging, but I have tackled it and I'm going to show you how I'm doing what I'm doing for us to get the right knowledge. We can observe from the question, we have there the coordinates given from the control points. We have P, we have TR1, TR2, TR3, TR4, TR5, and TR6, and our last control point we have there Q. Giving in the question, we are giving the coordinates. They expect us to use the datum coordinates in order for us to get the accurate final bearings that were supposed to be used in our bearing sheet. We can observe from P we have A, and from P also we have Q, and our last there point we have T R1. Let's go directly to the datum coordinates given to us. We are giving the datum coordinates for P, A, and Q. The northing and the eastings, so that those are the latitudes and the departures are used to calculate either the bearings and the distances. We can get either of them. In our question, we are interested with the bearings because, as we can observe, we are only given the observed bearings and we need the final bearings of at least 4 points in order for us to get the correction for the orientation. And what we are going to do, I found most simplified way. We are going to use a calculator. So in our calculator, in our normal calculator, that is the 82, the 82 series, the normal calculator that we use in the exam, not the programmable or the scientific calculator. We are going to use that calculator in order for us to solve these problems more efficient and more faster. First of all, we have other formulas that I've well taught you in the other videos, but today we are going to use a more simplified way. And in our more simplified way, we are going to find the differences in the northings and the eastings. Then those are the values you're going to input in the calculator. There I have shown you a formula. So that is the simplest formula that I found using a calculator. By the formula, we are going to start with, I want us to find the bearing of AP. And in finding the bearing of AP, so using the difference, so the difference between AP, so we are going to minus the northing of P to that of A, and also the easting of P to that of A. The difference in the northing of AP will be 2736.76, and the difference in the easting will be 4217.55. Those are the values that I'm going to input in the calculator. We go ahead using our calculator. I've demonstrated there how you are going to use the calculator. So you press the pole. So this is a polar, so polar coordinate. So we are going to pole these values in order for us to get the distance and the bearing. You pole, the pole already has a bracket there. Then the first value you input there, that is the northing. So that will be the northing that we had calculated earlier, that is 2736.76. We write a comma, so we input a comma there in the calculator, and then our easting, that is 4217.55. We close our bracket, and then we press the is equal sign. So when you press the is equal sign, you'll be given the distances, but as we are interested with the bearing, so you go ahead, you press the RCL, that is the calculator there. After doing that, you press the F. So I'll first make sure I pressed the there on top, then you press the F. After doing that, after pressing F, it gives us the final bearing. So that is just a simple way. I've demonstrated that. You can repeat that as much as possible for you to get this concept of calculation. After doing that, the value of AP, so that the bearing will be 57 degrees 1 minute 14 seconds. Then we are going to do that to the rest of our we are going to do to the rest. So I want to calculate as much as possible and find as many as I can find the final bearings, so that I can compare, because that will be the values that I'm going to be using there on my table. So for P, I make sure I calculate for PA, and for PQ, and then down there on my table I make sure I do the same for QP and for QA, because those are the values that I'm really interested with. By doing the same, so you make sure you arrange your work. The next one, let me calculate the bearing for PQ. So the bearing for PQ, that will be the difference when you write, that will be PQ. So I'm going to subtract the value of Q to that of P for both my northing and my easting. After which, so make sure you properly use your calculator. After which I'm going to get, so the difference in the northing will be 1568.49, and then my value for E will have a negative, so that is negative 6 or 3.05. Those are my values that I'm going to put in the calculator using the formula that I had earlier shown you. After doing that, my answer becomes a negative. So when my angle is a negative, by use of, so there was a formula we used to apply in high school. You can go and remind yourself the trigonometry equations. I will add 360 to my negative in order for me to get my final bearing, and my final bearing will be 338 58. That is a 10. I do the same to all my others, after which I will get all my values. So we'll try again for AQ. For AQ, we do the same, so we subtract the northing and the easting and we pole. So we are going to have a positive answer, so we don't have to add anything. That will give us a direct answer there, as you can observe. After doing that, I come again, So in order for me to get any value, I'll either use a back bearing of that value or a for bearing of that value in order for me to calculate whatever I'll be calculating in. After which I've displayed at least a number of angles there, and the angles I'm going to be using there are the ones that I've shown you. Having done that, I go back, I draw my bearing sheet, and in my bearing sheet we'll have the value for the line. We'll have the on our table we'll have the observation with the orientation correction, the preliminary adjusted bearings, the final correction, and the final bearings. Having done that, I start with my first value, that is from control point P to A. I write my value there, the one for observed value we had been given in our calculations. I write for Q and for T R. Then I had done earlier all my my calculations, so I already have the final bearings from what I had done earlier, from my polling, from the polls that I had done there. Those were from the polar coordinates, so I got there my final bearings. And from the 4 bearing of PA, that will be 237 01 14, and that of PQ will be 338 58 10, and those are the values that I'm going to use. First of all, so in our column for the observed bearings, in order for me to find the orientation correction, I will need to know how much will I do in order for me to get the final bearing which is correct. I'm going to take my final bearing, subtract it with my observed bearings, and I get there a positive. So that will be the angle needed in order for me to add to correct, in order for me to find the final bearing. I will do the same to PQ. I will subtract 338 58 10 from 338 58 08. Having done that, we get the orientation correction as 2, that will be seconds. So we subtract, and after subtracting we can observe that we need to add those values in order for us to get our final bearings. Having done that, I come on the orientation correction column. I add both my seconds, so that will be 15 plus 2, getting a total of that will be roughly 17. Having done that, we divide it by 2 in order for us to find the mean. After dividing it by 2, I find the orientation correction that I'll apply to the next point, that will be 8.5 seconds. We come to our next point. We can observe there we moved from P to T R1, and in our first observed, the value for T was 251.4403. We subtract in order for us to get the back bearing that was observed on our next point. Having subtracted that, my answer becomes 71 degree 44 minutes 03 seconds. We can observe on our next point written there. So from TR1 to P, the observed bearing had a little bit changed from our previous answer. I want to find my correction. So I will subtract 71.44.03 to 71.44.59, and I will get my correction. After which, that will be the correction that I'll add to my previous orientation there. Having done that, my correction becomes my orientation correction becomes positive 2 minutes 12.5 seconds. We write there on that column. Then we move to the next point. We can observe there from TR2 our value was 3000 not 3000 354.0305. Subtract by 180 in order for us to get the, so that was the back bearing, in order for us to get the fore bearing of our next point, and our fore bearing will be 174.0305. But we can see there from TR2 to TR1, there our back bearing was 174.0259. We subtract in order for us to find the correction, and after having subtracted that, we see our correction. So there the difference between the two will be positive 6 seconds. We add to the previous orientation correction, and we get there as 2 minutes and 18.5 seconds. The same is done. So from TR2 to TR3, there we have fore bearing of 44.0042. In order for us to get our back bearing, we'll add 180 degrees. Having done that, our answer becomes that will be 224.0042. We subtract with the value that we have been given there as our back bearing. So from TR3 to TR2, there we have a back bearing of 223.59.51. Having subtracted that, we see we need to add a lot. So you can observe in the calculator, I have done everything there, and that addition will be applied to the previous orientation correction. So we add that to 2 degree 18.5, so that is 2 minutes, so that is 2 minutes and 18.5 seconds. We add our correction. Having done that, we get our next orientation correction as 3 minutes and 9.5 seconds. The same is done. So we can observe there from TR3 to TR4, we have a fore bearing of 6, 19, 18. In order for us to get our back bearing, we'll add 180. After adding 180, our answer becomes 18 or 186, 19, 18. But there we have been given our fore bearing as 186, 19, 08. The difference in those two, that will be a positive 10. So we'll need to correct the value there by a positive 10 in order for us to get the right thing. And that positive 10 seconds will be added to the orientation correction that we had there. Having done that, our orientation correction becomes 3 minutes 19.5. Again, we move on to our next calculation. On our next calculation there, we can see So that is 76 10 13 added by 180 in order for us to get the back bearing. That will be 256 10 13, but we can see there our observed value was 256 10 05. So by subtracting that, we get a positive 8. That positive 8 will be added to the previous that we had there. So my previous there was 3 minutes 19.5 seconds added by when you add that 8 there, we get 3 minutes and 27.5 seconds. And then we move to our last but not least. So we can observe there we have been given a 4, that is the 4 bearing there as 2 38 05 20. In order for us to get the back bearing, we'll subtract 180 degrees. After subtracting 180 degrees, there we have our answer as 58 05 20. But there on our observed column we had been given 58 05 14. By subtracting that, we find that we have a positive correction there of 6. By adding that to the previous, our answer becomes 3 minutes and 33.5 seconds. Then we move to the last section there, and that section is so that section becomes so our value there, we had been given a 4 bearing from TR6 to Q. Our 4 bearing was 286 36 25. Subtracting 180 degrees in order for us to get our back bearing. Our back bearing will be 106 36 25. But in observed section there, the back bearing was given as 06 36 21. By subtracting that, we get a positive 4, and that positive 4 will be added to our orientation correction, the previous orientation correction there, and that orientation correction is 3 minutes and 37.5 seconds. That will be applied to both P and A. Having finished that side, we move on to our next section. We move to the preliminary adjusted bearings, and in our last part there, in P and A, the observed values, we correct them first. Having corrected that, so that is 158 57 58. Then we add 0 degrees, 3 minutes and 37.5 seconds. We get our final value as 150 9 0 1 36. We do the same to A, that is 121, so that is 219 59 59. We add 0 degrees, 33 minutes 37.5 seconds, and we get our final value as 220 03 37. Having done that on the preliminary adjusted bearings, we have our final bearings that we had calculated earlier from the coordinates, the datum coordinates that we have been given. We need to see what was done on what needed to be done in order for us to get our final bearings that we had observed. By looking at those values, we need to subtract, because the preliminary adjusted bearing, those values are higher than the final bearings. By subtracting 158.10 from the final bearing to that value of P in the preliminary adjusted bearing, 159.0136, will get negative 0 degrees 3 minutes and 26 seconds. Then the same will be done to A. So from Q to A, our final bearing was 220.055, and in the preliminary adjusted bearing, our value was 220.0337. By subtracting that, we get a negative, because we needed to subtract that in order for us to get the final bearings. That will be 0 degrees 2 minutes and 42 seconds. Having done that, we add the 2. After adding the 2, I divide that total with the number of stations. We had 8 stations there: P, tier 1, tier 2, tier 3, tier 4, tier 5, tier 6, and Q. Those were 8 stations. Yeah, you can count them. Those were 8 stations. By dividing that, then I find now my final correction, and my first final correction is 0 degrees. That is a negative 0 degrees 0 minutes and 46 seconds. That will be applied to station P. Then on station, so that I will correct that in the P column there. After having done that, I will apply that final correction by adding that error in a sequence. So I'll add 0 negative 0 degrees 0 minutes and 46 seconds by the same 0 degrees 0 minutes and 46 seconds, and I will get the final correction applied to tier 2 there as 0 degrees 1 minute 32 seconds. Then to that, I'll add again the 0 degrees 0 minutes and 46 seconds to that, and after adding that, I will get my next as 0 degrees 2 minutes and 18 seconds. Now in the 2 minutes and 18 seconds, I will add again the 46 seconds, and I will get 3 minutes and 04 seconds. I'll again add the 46 seconds to that, and I will get a negative 3 minutes 40 and 50 seconds. I'll again add that 46 there, and I will get a negative 4 minutes and 36 seconds. That too, I'll add again the 46 seconds, and I will get a negative 5 minutes and 22 seconds. Having done that, I move back to my preliminary adjusted bearing. So we add the orientation correction to the observed values, and after having done that, so when you do that, you add the observed value and the orientation correction, you will get your final preliminary adjusted bearing. On that preliminary adjusted bearing, you subtract the final correction to find the final bearing. So you use your calculator well here, and the same will be done to all those stations. So you add the observed value, so the observed bearings, you add the orientation correction, and when you add that, you will get the preliminary adjusted bearing. And when you get the preliminary adjusted bearing, you subtract the final correction. And when you subtract the final correction, you will get your final bearings. And that will be done to all our other parts. And finishing that, you will be set and good to go.